We're going to talk about factoring. And I don't know, again, how long ago any of you did factoring, but we're going to try and review it and learn it for the first time, or really a lot of refreshing, or refresh a little bit. So first thing you have to understand is what factors are. Factors are things that are multiplied together to get a product. So like we talk about factors of 6. And 2 is a factor of 6 because 2 times 3 equals 6. So 2 and 3 are both factors of 6. Just like 1 and 6 are factors of 6 because 1 times 6 equals 6. So factors are just things that multiply together to equal some number or some thing, some value. So we are going to start out with what is called factoring out a greatest common factor. So just to read this to you, this one says 3x squared minus 6x. So 3x squared minus 6x. And again, I apologize for not having those. I had them printed at my house. Anyway. The second one, I'll go ahead and read that to you. This one says 8x to the 4th power, y to the 2nd power, plus 6x cubed, y cubed, 3rd power for both of those, minus 2xy to the 4th. And hopefully as I'm writing these, you'll be able to see that fairly well. But now I'm not going to always do this, but for this first one, I want to show you exactly kind of what's going on here. So I'm going to write it out as each of its little factors. Okay, so this is a 3. You can't break that up at all. X squared you can write as x times x. So we have 3 times x for that first term. And again, I'm not going to do this every time, but just so that we can visualize again what's going on here. Then we've got a minus sign. How can we break up the 6 into its factors? Does it make sense? That'll be 2 times 3. Okay, so 2 times 3, and then we have another x on the end. So here's the first term, here's the second term. Each of these individual pieces is called a term. Now what we're looking for is, what do they have in common that we can factor out? So if we look at this and we look at the numbers first, what do they both have in them?
3.
A 3. So we're going to be able to factor out a 3. And that's the number part that they both have. And then if we look at the variable part, what do they both have in them?
X.
An x. So we're going to be able to take out one x because they both have at least one x in them. So we're going to take out a 3 and an x. Factor out a 3 and an x. Now, after we factor out the 3 and the x, what do we have left in this first piece, this first term?
X.
Just an x. Does that make sense? Okay, and then we've got our minus sign. And then after we factor out the 3 and the x over here, what do we have left in that second term?
2.
The minus 2, right? And so that is factoring out a greatest common factor. So now we know this thing times this thing equals this original piece. So these are the factors. Okay? Now one thing I'll mention, it's important to remember that when we factor out, we are actually, because what do we normally do when we see something like this?
Distribute.
You normally would distribute, right? What we're doing here is the opposite of distributing. So we are not, remember when you distribute, you multiply through the parentheses? Here we're actually dividing out a 3x from both of these. And I want to try to say dividing out rather than taking out, because people, when they hear taking out, they think subtraction. And we're not subtracting, we are dividing each of those terms by a 3 and also by an x. Okay? So that's the first one, 3x times x minus 2.
I got a question.
Yes?
You're 2 and 3 to 6.
For the 6, we just did, we did what's called prime factors of 6. So if we take 6 and we break it up as far as we can, you can break it up into 2 times 3, and you can't break up the 2 or the 3 any further. And so that's what we did there. And again, we won't normally do that. It's just so that we could see all the little pieces separated. But that's where the 2 and the 3 came from. Okay, any other questions? So moving to this one, if we look at our numbers first, and I'm not going to break it all up this time, but let's look at the numbers and let's think about what can we divide out of all 3 of these, out of the 8, out of the 6, and out of the 2?
2.
2, right? So we can factor out a 2 from each of those, and we'll do that in a second. The next thing we have is x to the 4th, which is 4x's, x to the 3rd, which is 3x's, and x, which is obviously just 1x. So how many x's will we be able to take out?
1.
Just 1, right? You can't take out 2 because this one doesn't have 2. So we can only take out 1x. And then we have y squared. Again, that's 2y's. Y cubed, 3y's. Y to the 4th, 4y's. So how many y's will we be able to factor out?
2.
2. Very good. Okay. Now we have to figure out what's left. And remember, we're dividing. So if we look at this first term, we'll start with the number 8, and we're dividing out a 2. What's going to be left? 4. We've got x to the 4th, and we're dividing out 1x. What's going to be left there?
X to the 3rd.
X to the 3rd. Okay, it's like you had 4 x's, you factored out one of them, you've only got 3 left. Okay, and we had y squared, and we factored out y squared. Yeah, there are no y's left. So that's the end of the first term. Then we go ahead and put in our plus sign. And we go to the 6. We're dividing out a 2. What's going to be left there?
3.
3. We've got x cubed. We're dividing out an x. What's going to be left there?
X squared.
X squared. And then we've got a y cubed, and we're dividing out a y squared.
1.
Just a y. Okay, and then we'll put our minus sign in. And then 2 divided by 2.
2. Negative
But what is 2 divided by 2?
1.
1. Okay, so I'm going to put the 1 there. We may or may not need it, because if there's anything else, we don't need that 1, right? But if there's nothing else, then we need the 1. All right, x, and we're dividing out an x. That's 1 again, right? So we don't need another 1. Y to the 4th, we're dividing out a y squared.
Y squared.
Y squared is going to be left over. So I'm going to go ahead and put this there. But just understand, we don't really need that 1 anymore, right? Because there's automatically a 1 there, even if we don't have it written. And so that is, again, that's our factorization of this one. So that means this times this big bunch of stuff. If you distribute it again, it would equal this. Okay? So it's important to understand that we're doing the opposite of distributing. We're dividing out something. Any questions on those first two? All right. Let's go on to something that looks more confusing, but is actually exactly the same thing. Okay? Now, here's what we need to understand. Our terms are separated by plus and minus signs. So this is actually just one big term. Right? There's no, this is one piece, this is another piece, but there's no plus sign in between them. So it's one big term. This is another big term. Not quite as big as the other one. Now, if you look at this, what do they both have in them?
X.
They both have this x minus 3 in parentheses, right? He said parentheses. Yeah, they both have parentheses. But what's important is what's inside the parentheses. They both have this x minus 3. So that means we can factor out the x minus 3 that, yes, is in parentheses. Making jokes back there. Good. It keeps the class fun, right? Okay. So we factor out the x minus 3. Now, here's what we have left. And I'm going to use a bracket here just to, because I'm going to have some parentheses inside of this. You could just use bigger parentheses. That's fine, too. But what's left in this first piece after we factored out the x minus 3?
2x plus 4.
The 2x plus 4. Oh, I forgot to read this one. Can everybody see it okay? Okay. And then we have the minus sign. And what's left in the second piece after we factor out
Minus 5.
the minus 5? Okay. Now, at this point, and most of ours that we do tonight won't be like this, but in this particular case, do we see that we can actually simplify this? Because these parentheses were important because this was multiplied by this. But they're not important anymore because 2x plus 4 is just minus 5. Right? Yeah.
What's the reasoning behind the bracket?
Just because there was a parentheses inside, and I didn't want to confuse which parentheses went with what.
Oh.
But you could just use bigger parentheses. That's fine, too.
Okay.
But it's this whole thing that's multiplied by the x minus 3. So that's what we were doing. That whole thing gets multiplied by this because it got factored out of the whole thing. So here's what we can do at this point. We just copy down our x minus 3, but does it make sense that we can combine those two? Because it just means 2x plus 4 minus 5. And so we have 2x, and this would be minus 1, 4 minus 5. Okay. And like I said, I think this is the only one all night that has that parentheses like that in there. The rest of them it'll be two things and you'll be done. So that'll be nicer. But again, what this means is if we would multiply these two together, it would go back to this. If you simplified this. This one is not simplified, so we wouldn't normally see it like that. But this is just, we're going to see a lot of things that look kind of like this. And so I wanted to show you that you can actually factor out any factor. So this x minus 3 is a factor, we can factor it out as long as it's in both. Okay. All right, so we got our answer there. Oh, this is a good time to point this out too. The order that you write these factors in doesn't make any difference. Because when you multiply things, isn't like 5 times 2 the same as 2 times 5? The order that you write multiplication in doesn't matter. So it's okay to have it written like that or have it written like this. The order doesn't matter as long as the factors are correct. Okay. All right. So now we're going to learn a little process called factoring by grouping. Okay, and we kind of did the end of it on that last problem. But when we factor by grouping, you can only do this if you have an even number of terms. And the ones we're going to do, you're going to have 4 terms. So I've got my first group, and I've got my second group. And we just group them first 2 and second 2. So those are our 2 groups. Okay, everybody okay with that? Just half and half. Oh, by the way, this says 12n to the 3rd power plus 4n to the 2nd power plus 3n plus 1. So let's look in our first group. What do we see if we're just looking at these 2? What can we factor out of both of these?
And an n.
A 4 and an n. Not just a 4 and an n, but a 4 and an n squared. Right? They both have at least 2. And what's going to be left after we divide out the 4n squared from this part?
N.
And?
3.
Yeah, 3n. And then what about from this part? If you take 4n squared and divide out a 4n squared, it's going to be 1. Right? Divide something by itself equals 1. It doesn't just disappear. It still equals 1. And then whatever this sign is here, it always goes here. Okay? So what can we factor out of both of these? Yeah, if these are your 2 terms,
1.
can we factor anything out of here? They don't have anything in common. So we're just going to write down 3n plus 1. But we want to view it as 3n plus 1, right? We want to view it as a group. So what does that mean is automatically in front of here? A 1, right? If there's ever a spot that is in front of a parentheses or anything, it's automatically a 1. And we actually want to put that 1 there in this case because now we have our first half is still right here. I should have used a different color maybe. Our second half is still right here. What do we see that we can factor out of both of those then?
3n plus 1.
3n plus 1 is correct. So we're going to factor out this 3n plus 1 from both of these. 3n plus 1. Okay? Then, if we look at this first part, what's left after we factor out the 3n plus 1?
4n squared.
4n squared is left from that first part plus
1.
1 from the second part. Okay? And that's our answer. And this is what your answers are going to look like on your homework. You're just going to write these 2 parentheses down and put the numbers inside of them, or the variables and numbers inside of them, and that will be your answer. And again, what it means is if you multiply them together, you're going to get back to here. Okay? And you're going to see at the end of class why we would want to do this. We'll do some problems and then we'll find out why we want to do that. Any questions on that one before we go on? All right. Oh, yeah, that's the answer. Again, the order doesn't matter. Now, I did switch these around. This is not in what we would consider standard form, because normally we go n cubed, n squared, n, and a constant. But I switched them around on purpose just because I want you to see something. So we're going to leave them as they are. And we're going to deal with the first group and the second group. And we're going to look at the first group, and we're going to say, okay, if these are the two numbers we have, do I need to read these?
Please.
Okay. 5n cubed, n to the third power, plus 3n minus 10n to the second power minus 6. Okay, so if we're looking at these first two, what do we see that we can factor out of both of those?
N.
Yeah, just an n, that's all. So if we factor out the n, what's going to be left? 5n squared
plus 3.
plus 3. Is everybody okay with that so far? Now, here's the part we have to remember, and that's why I rearranged this example. Whatever sign is right here, you have to factor out. Now, if it's a plus sign, it doesn't really matter. But if it's a negative sign, it's very important. Then we look at these. What can we still factor out of those two?
2.
The 2, that's correct. Now, when we do this, remember we're dividing. Are we okay with the 2? Do you have a question?
Yeah, why do you gotta?
So we're looking at what can divide evenly into the 10 and to the 6,
Okay.
and 2 is the biggest. Okay, so then our goal is to divide out the negative 2. So we have to think of, this is negative 10n squared divided by negative 2. What will that be?
Negative 5n.
Positive.
We have to be careful.
Oh, yeah.
A negative divided by negative
It's
is
positive.
positive 5n squared, right? Okay, and then we've got negative 6 divided by the negative 2.
3.
Plus 3, right? Yeah, positive 3. And notice, in this case again, at this point, this factor right here and this factor right here, because we're still dealing with first half, second half, right? Here's the first half, here's the second half. Do we see how we can factor out 5n squared plus 3 from both of those?
Mhm.
Okay, so 5n squared plus 3 would go in the front. And then what is left after we factor that out of each piece? From the first half we get an n, from the second half we get minus 2. And that's our factoring. And we're done. Okay? That making sense so far? Okay? That process right there, that factoring by grouping, we're going to be using that a lot the rest of the night. So if you don't quite get it yet, you're going to get a lot more practice. Okay? And if you have questions, please ask. Any questions on that, though, before we go on? All right. So our main focus tonight is on these types. And this says quadratic. And quadratic functions have this sort of a form. It's a number, which we label with a, times x to the second power, plus another number, which we label as b, times x, plus another number, which we label as c. So that's just so we can keep track of which number we're talking about, the a, b, and c. But they're just numbers in front of the variables. Okay, and I'm going to have 4 steps here that we're going to be doing to help us factor these. This will be a review for some of you who were in my class last semester, but here we go. And don't worry about this part. Just we are going to use a 4-step method to factor. Okay, and here's our first step. We're going to multiply the a value times the c value. So that's this very first number times this very last number. We're going to multiply those two together, a times c. Then we're going to find the factors of that product of a times c. And we're going to look for the factors that have a sum of b. So we're going to find 2 numbers that multiply to be a times c, but will also add up to be this middle number, b. It's okay. You're going to do plenty of examples. So you'll see, we're going to go through this process over and over and over again. So, but it's they have factors of A times C that add up to BB. Okay, and again, I know for some of you this doesn't mean anything right now, but when you see it, you're going to see us going through these steps every time. That's fine. That's fine. This is just to help you remember when you go back. Then we're going to take this expression here and we're going to rewrite it. And we're just going to copy down the ax squared and we're going to copy down the c. But this middle term, we're going to split up using those two factors we just found in this second step. So we're going to take this middle term and break it into two pieces, which may give you a hint because now we're going to have 4 terms instead of 3. And then we're going to be able to factor by grouping. So that's our last step, is we're going to factor by grouping, which is what we were just practicing on those last couple of examples. Now, I will tell you there are other methods of factoring, but as far as just trying to get one method that always works, this is the one that you can just do it and it pretty much always works. Okay, so that's why I'm going to just stick with this one, and that way we all have a common reference of how we're going to work on trying to factor these. If you have your own method that you already know, totally fine. Okay, I'm not going to, I don't care if you use that, that's fine. It's not going to hurt my feelings. But this is one that will work all the time, so we're going to learn this one. All right, so, but one thing I'll mention is remember to always look for a common factor first. Because if you can factor out something at the beginning, it's going to make all the rest of your numbers and everything smaller, and it'll make your life easier as you try and do this factoring. Okay, so always look for a common factor from your terms first to see if you can get that out of there, and then you can go on. All right, so let's get to it. First one. It says x squared plus 7x plus 12. So we're going to start with a pretty basic one. Okay. Now, before we go on, so x squared plus 7x plus 12. Before we go on, we want to remember, what's the a value here? What number is in front of this x squared? 1. And that sets us up for our first step. And our first step says we want to multiply this a times the c. So in this case, that is 1 times 12. And we know that that's 12. Right? Now, before we go on to step 2, I want us to do some thinking. I know it's rough to think sometimes, but let's see if we can kind of process through this. Because I could just write every possible factor of 12 because 12 is not very big. But some of the numbers are a little bit bigger, and this will save us some time later on. So here's what we want to go through and we want to do. We always want to look at, let me switch colors here. We always want to look at this sign right here. Because this sign right here will be the same as this product. Okay? And so here's what we want to think about. Step 2 is for us to find factors of 12. Right? And 12 is positive. So here's what we want to think about. If we multiply two numbers together and get a positive answer, what does that mean about the two numbers that we're multiplying together? It could mean two different things, right? It could be that they were both positive like this, or, and I heard somebody say it, but you got math on, I can't tell. It could be they're both negative. Does that make, you remember that from who knows when, how long ago, but a negative times a negative equals a positive? Okay, so here's what this part tells us. It tells us these are either both positive, that's 2 plus signs, or they're both negative. And that's just to remind myself, either both positive or both negative. So does that part make sense? If this number over here is positive, then your two factors you're looking for have to be the same sign. Here's the next thing. We wanted those factors that we're looking for to add up to be what? In this case, b, and b is 7, right? But what's important about that 7 is positive. Now let's go back over here. If I add two positive numbers together, the result will be what? Positive. What happens if I add two negative numbers together?
Positive.
Add.
Oh,
If you
Negative.
add two negatives together, it'll be a negative, right? So that tells us this is what we want. We're looking for positive factors. Does that make sense? And if it doesn't now, we're going to do it a whole bunch of times. So hopefully by the end of the night, it will make sense. Okay? So now we start listing our factors, and we know from this thinking that we're looking for positive numbers only. So factors of 12, and I just start writing them down, 1 and 12. And that multiplies fine, but does that add up to be 7?
No.
No. So then I just go to the next one, 2. Well, 2 goes into 12 6 times. Does that add up to be 7? No, pretty close, but no.
3 and 4.
Then I go to the next one, and it's 3, and 3 goes into 12 4 times. Does that add up to be 7?
Yes.
Yeah.
Yes. So now we've found the ones that we want to use, 3 and 4. You got to find the right ones. So 3 and 4. Now, we've done step 2, right? We've found the correct factors. What we do now is we rewrite this. X squared and the plus 12. But we break this middle term into 2 pieces using these 2 numbers right here. So it's going to be plus 3x and plus 4x. And that's okay because does it make sense that 3x times 4x equals 7x? Right?
Mhm.
And as long as we do this part right, this should be okay. Now, we have 4 terms. We just learned how to factor things with 4 terms, right? So we're going to divide this into 2 groups. What can we factor out of the first group? X. And what's left?
X plus 3.
No.
Just x plus 3, because we already took out one of the x's. Then remember, we have to take out the plus sign. And what else can we take out of the second group?
4.
A 4. And what's going to be left?
X
X plus 3, because we're dividing them both by a 4. Now, here we have it. And as long as we did our work over here correctly, these will match up. Okay? They will, if we did our work right over there. So we can factor out an x plus 3 from both of these. And then what's left after we do that? X plus 4. And that's our answer. Once we get to here and we have our 2 factors in parentheses, we know we're done. And we're going to just do that a whole bunch of times tonight to practice it. Okay?
So I'm confused.
Yeah.
On that very first step, the 1 parentheses 12. Yeah, that whole, how did he get to that?
How do we get the 1 times 12? Or how do we get to over here?
The whole 1 parentheses 12 equals.
Okay,
that.
so the first thing we did is we always take the A value, which is this number right here, times the C value. So that's where the 1 times 12 came from. And then that equals 12. So that just says equals 12. Okay, and then was that as far as you needed, or
Yeah, that's okay.
that's what you were wondering?
Yeah.
Okay, good.
I was a little lost. I didn't know where.
Yep, and we're going to do that a whole bunch of times, so you'll see it again. And if you're still lost, then make sure you ask again, because we'll get it figured out. Okay, so there's our factors. And again, if you multiply these back out, it would equal this. Okay, but again, right now we're trying to break them apart, so we don't want to multiply them back out, but you can check it and see if you had it right. All right. This one says x squared minus 2x minus 3. X squared minus 2x minus 3. Another fairly basic one before we move on to some other ones, but it gives us another look at this. Again, what number is automatically in front of the x squared? A 1. Okay, so our first step says 1 times the negative 3. So I'm just going to go over here and do that. And what do we know that 1 times negative 3 is? Negative 3, correct. So here's where, again, we want to look at our signs. If we multiply 2 numbers together and we get a negative answer, what does that tell us about the signs of the 2 numbers that we're multiplying together? One is positive and one's negative, right? That just happened, right? Positive times a negative. And that's what has to happen if you get a negative answer. So we automatically know 1 is positive, 1 is negative. But these 2 numbers we're looking for have to add up to be negative 2 in this case. So now we want to look at, what does this sign tell us? Last time it told us they were both positive. You can't tell us that this time because they're different, right? One's positive, one's negative. It means the bigger one, if you're adding two numbers together and one's positive and one's negative, how do you figure out what the answer is? Positive or negative? The bigger one, right? If you got like a negative 10 and a positive 2, does it make sense the negative one is going to outweigh the positive one? It's like if you go to the bank and you have spent $10, but you only had 2 in the bank, how happy is the bank with you? Not very happy, right? Because now your account is negative. On the other hand, if you have a positive 10 and a negative 2, that will result in a positive still, right? So this tells us the bigger one is negative. So we're just going to circle that one to say, okay, the bigger one is going to be negative. All right, and there aren't many options here, but let's take a look. Factors of negative 3, we've got a 1 and a 3, and the bigger one has to be negative. Does that add up to be negative 2? Yes, so actually we found it the first time, right? So we're going to use these. And we're going to come over here, and remember, we're going to rewrite this. So x squared plus 1x minus 3x minus 3. And remember, this is okay because we've just broken that middle term into 2 parts. And 1x and a negative 3x add together to be negative 2x. Now we have our 2 groups. What can we factor out of the first group? An x. And what's left?
X.
Correct, x plus 1. We have to take out the negative. And what's going to be left in the second group? Or what else can we take out of the second group? A 3. So remember, we're factoring out a negative 3. What will be left then? If we factor from the first one, it'll be an x. And what happens when we divide out of the second one?
1.
Plus 1, right? Negative 3 divided by negative 3 is plus 1. And again, as I mentioned before, as long as you did your work right over there, these should match up. And they do. So we're going to have x plus 1. We're going to factor that out. And then what do we have left after we factor out the x plus 1? Correct. Now, some of you who are really paying attention may have noticed that in these 2 examples, the 1 and the negative 3 went into the parentheses at the end. And in the last one, it was, what was it? 3 and 4? Whatever it was, like 3 and 4. And it was x plus 3 and x plus 4. That is a little shortcut you can use as long as this first number is a 1.
That's what I couldn't remember.
It only works when that first number is a 1. So that's why I don't really teach that as a big deal. But it will happen sometimes that those numbers will just pop down into here. And it happens when this is a 1. If this is not a 1, then it won't happen.
I have a question.
Yeah.
So if I did the
Oh, great question. Okay, so Gancha's asking, are you asking if you switch the 1 and the 3 around? Okay, so I want to show you what happens. So I put mine in this order, but you might have it in a different order, and you might wonder what happens. So if we've got, and I'm going to do this one fairly quickly, if we had switched the order and we had minus 3x and then plus 1x and then minus 3, notice that our pairs are a little bit different then. Our halves are a little bit, our groups are a little bit different, right? But what could we still factor out of the first half, the first group? An x, and we would have x minus 3. And we have to take out the plus, and what can we factor out of the second one?
1.
Nothing or a 1, and so the 1's automatically there, but we have x minus 3, right? Then we could factor out the x minus 3, and what's left?
X plus 1.
X plus 1. So notice, remember the order doesn't matter? So it doesn't matter. It's not like you have to magically pick the right order to put these in. If you put them in the other order, you're still going to get the same answer.
But it's okay.
Yeah. Yep. So this is the exact same answer as this. It's just the order is different. And nope. Now there are a few where it will say, like when you're solving things, it'll say put the smaller one first and the bigger one second or something like that because it has 2 separate boxes and then it's only looking for 1. But when you do this, it's pretty good about finding that you have the right things. I will say one of the most common mistakes I see people make on these, and even on some of the ones you guys did last week, is you'll like forget the x or forget to put something in. If it was like 2x minus 1, they'll just put 2 minus 1 and they forget the x or whatever variable it happens to be. So make sure that you're careful when you write them in. But yeah, it doesn't matter which order. All right, so we've got our answer. Let's go on and see what happens when we have. And I should have been doing this whole time. Let's see what happens when we have a number other than a 1. Now, the first thing I actually should have been doing every time, but because it was just an x squared, I didn't, is looking to see if there's any common factor that we can factor out of all 3 of these terms. But when you have a 1x squared, really that option is gone. So do we have any numbers that we can factor out of all of these?
7.
Yeah, it looks like 7 because 7 works here and 7 works here and 7 doesn't quite work here. Okay, 35 it would work, right? But not 45. So, but you always want to look for it, right? You always want to look for it. So, unfortunately, no, we can't factor anything out, but we always want to look, especially if there's a number there, because it might factor, and then we can have an easier process.
But we don't have to, right?
What?
I mean, we have.
Eventually, eventually it's going to come out one way or the other.
Mm.
It might be at the very end, or it might be at the beginning. It's just going to make your life easier if you do it at the beginning. So, our process, and I'm going to need somebody with a calculator to help me out here. We're going to multiply 7 times negative 28, right? A times C. So if somebody can help me out, I know it's a negative.
Can you read the problem?
Oh, I'm sorry. Yep. 7x to the second power minus 45x
X or E?
x minus 28.
7X, right?
7x squared.
Thank you.
I have a.
Okay. So what did we say? Negative 194? Is that 196? Okay. Okay. So again, we want to kind of go through our thinking process to help us know what kind of numbers we're looking for. Since this is a negative and our 2 numbers are going to multiply together to give us a negative, what do we know about the signs of those numbers? One's positive, one's negative. And again, you can see that right here, right? One's positive, one's negative. So that has to be true. One positive, one negative. Then we look over here. And since they're going to add up to be negative 45. So what does that tell us? Since they're different signs and they add up to be a negative, what does that tell us? The negative one is going to be bigger because that negative is going to outweigh the little positive number, right? By 45. So the negative one is going to be bigger. So let's start working through this. And again, guys, I'll just tell you right now, the better you are at your multiplication tables, the easier this process is. I don't expect you to go memorize multiplication tables, but if you already know them and you can jump right to the right answer, that's totally fine. I'm going to go through each one in order so that you know if you just keep writing them down, you'll find the right one. Okay? So I always start with 1, and obviously 1 goes in there 196 times, and we know the negative one is supposed to be the bigger one. So does that add up to be negative 45? No. Then I would go to 2. 2 divides into here negative 98 times. Does that add up to be negative 45? No. 3. 3 won't divide in there. You can check it with a calculator. It doesn't work. So we're going to go to 4. 4 divides into that negative 49 times. Does that add up to be negative 45? Yes. That's the one that works, right? Positive 4 and negative 49, add them together, negative 45. Okay? And again, you can use a calculator. I'm going through that part kind of because I know you can just type it into a calculator. So remember now we're going to rewrite this. 7x squared plus 4x minus 49x and minus 28. And again, just to emphasize, we're not making up things. The reason we can do that is because those 2 together equal the middle one. We're breaking that middle one into 2 convenient parts. So for our first group, what can we factor out of both of those? Just, I mean, depending on the order you put in.
Yeah,
My
sorry.
order, I can just factor out an x. And what's left?
7X.
7x plus 4. If you switch the order, you can factor out a 7x. But I have it this way, so I always put my smaller one first just because of my chart. All right, then remember we have to factor out the negative if it's here. And then what else can we factor out of both of these? 7. So our 7 is in the second one. And then after we factor out the negative 7, what will we have left in this first term?
7x plus 4.
Positive 7x. And then you're right, negative 28 divided by negative 7 is plus 4. And again, these should match up. So we kind of have a head start. We know what it should be. So since we have 7x minus 4 and 7x minus 4, we will factor out the 7x plus 4. I was saying it wrong a whole bunch of times. 7x plus 4 and 7x plus 4. We can factor out the 7x plus 4. And then what do we have left after we factor those out?
X minus 7.
X minus 7. And then we're done. And again, if you switch the order of your middle two terms, you'll just switch the order of your factors when you're done, and that doesn't make any difference. Okay? Any questions on that one? Are we starting to see how this process kind of repeats? I mean, you just do the same thing every time. That's what makes it nice, but also a little bit boring because you do the same thing every time.
I like boring.
You like boring? All right, well, good. I guess that's good. Okay, looking at this one, here's what it says. 2x squared plus x minus 6. All right. And again, before we get started, is there anything we can factor out of all three terms? Yeah, it looks like it, but then if we're careful,
Nothing.
can we take a 2 out of here?
No.
No. So not in this case. So that means we're back to a times c. 2 times negative 6, which is negative 12. Okay? And again, if we start examining our signs, the fact that this is negative tells us what about the signs of the numbers we're looking for? One positive, one negative. Yep. So one positive, one negative. Then we look back over here. And what does that tell us? The bigger one is positive, right? Because the bigger one has to outweigh the positive one outweighs the negative one. So bigger one's positive. So when we start writing these down and I've got my 1 and 12, I know the bigger one's positive, the smaller one is negative. Does that add up to be 1? No. So then we go to 2. 2 divides into there 6 times. Does that add up to be 1? No. 3. Negative 3 goes in there 4 times. Does that add up to be 1?
Yes.
Yes. So that's the one we're going to use. And again, if you know your multiplication tables, you can probably jump to 3 and 4 right away. But if not, just start writing them down and go until you find one. All right. So we split this up. 2x squared minus 3x plus 4x minus 6. So then we've got our 4 terms. Remember, we do this always to get our 4 terms so that we can factor by grouping. And we look at the first pair. What can we take out of both of those? Just an x. And what do we have left? 2x minus 3, correct? And then we've got our plus sign, so plus. What can we take out of the second pair?
2.
A 2. And after we factor out the 2, what's going to be left there?
2 minus 3.
2x minus 3. And again, they match up, right? So we can factor out 2x minus 3. And what do we have left?
X plus 2.
X plus 2. And we're done. All right, are we getting it? Okay. Better than you've ever known it before, right? For sure. Okay. All right. So if I do this one, are we feeling pretty good about the factoring? I don't remember if I have any more of these, but I don't want to like kill everyone with factoring. So we do have some other things to look at, but this is the main thing. So do we have anything we can factor out of all the terms?
No.
No. So we're going to go with a times c 2 times 20, and that gives us 40. And because that is oh, sorry, 2x squared, I forgot, just remind me, it's okay. 2x squared minus 13x plus 20. So 2 times 20 is 40, and it is a positive 40. What does that tell us about the signs of the numbers that we're looking for?
Same.
They're the same, either both positive or both negative, right? If they multiply together to be a positive, it could be like this where they're both positive, or it could be that they're both negative. Is that okay? When this is a negative, we have different, but when it's a positive, we have the same signs. So either both positive or both negative. Then we go over here, and in this case, it's a negative 13. So if they have to add up to be a negative 13, what does that tell us? I heard a couple different things, but hopefully what you're saying is that they're both going to be negative, right? Because if you add two positives together, you get a positive. And we need to have a negative, so we need to add two negatives together. Okay? So let's go to our factors. 1 and 40, but they're both negative. Does that add up to be negative 13? No. 2 and 20, both negative. Does that add up to be negative 13? No. 3 does not divide into 40. 4 does 10 times. So does that add up to be negative 13? Really close, but not quite, right? Negative 14. 5 divides into 40 8 times. Does that add up to be negative 13? That's the winner. Okay? So then rewrite 2x squared minus 5x minus 8x plus 20. And again, this is okay because those add up to be negative 13. Then we've got our 4 terms. First group, second group. What can we take out of the first group? Yeah, just an x if you've got them arranged this way. And what do we have left? Okay. And we have to take out this minus sign. And then what else can we take out? 4? Yeah, you can take out 2, but you want to take out the biggest thing, so you can actually take out a 4. And if we divide by 4, negative 4, what's going to be left here? 2x, positive 2x, and then minus 5, right? And again, they should match up, which they do. So that means we can factor out. And what do we have left? Correct. If these ever don't match up, double check. One of two things happened. Either you picked the wrong numbers over here, or you missed a sign, or you divided wrong or something. Or maybe you didn't factor out a big enough number or something. But they should match up. If you did your work right over here, these should match up. Okay? Oh, and I'm going to pause right now to tell you, the ones that I'm giving you, most of them are factorable, but like anything in math, there are times when you can't factor stuff. So if you go through your whole list and you can't find any numbers that add up to be what they're supposed to be, what that means is you can't factor that, that quadratic. And so there might be one in the book like that, and I think they just say, in general, if you ever can't factor it, you just write prime, like you can't break it up. So if you ever run into that, that can happen at times. So if you ever go through your list and you go all the way down and get to the end and you can't find any that worked, and you know you got them all, then that would be a situation, it's prime. Okay? So any questions on that one? Are we feeling pretty good about that? Okay, but again, always look for that common factor first. I've got another one here, but we're just going to skip through it because you guys said you could. A couple things that I want to show you, or really one more about factoring, and then one thing about solving. So we've got really one special pattern that I would suggest trying to learn, and it's this one right here. This special pattern is called the difference of squares. It's called the difference of squares because it's subtraction, which means it's a difference. And then the two things you're subtracting are both perfect squares. So this is where it gets its name, right here. So you're going to start with this, a squared minus b squared. If you are asked to factor that, it will always factor into these two things, which are exactly the same, except the middle sign, one of them is a plus and one of them is a minus. Okay? It will always factor that way. And this is one that we're going to try and use because this one is not hard to memorize, and it's probably the most helpful one. We can still do it the other way, and I'll show you how, but it's nice to have this rule. Okay? The other two equations that we have, you can write them down or not. I really don't care. We're not going to really use them. But here's what I would suggest understanding. Sometimes when you factor something, you can end up with two factors that are exactly the same. And that's what this means. You factored it and you got two things that were the same. That's what this means right here. And that can happen, and that's not a problem. Okay? So, but as far as using that pattern, I would say just use what we've already learned and do that. Because by the time you figure out that it's that pattern, it's not really worth the time. And then you have to memorize all this stuff too. So I would say this one is probably worth memorizing. These, not so much. All right, but let's do some examples of the difference of squares one, which is the one that I would suggest we do try to learn. Now our first hint, well, first thing, can we factor anything out of both of these?
Yeah.
What?
3.
Yes for the 9, no for the 16.
No. Oh.
Right? So no, we can't factor anything out of both.
Wow. Oh, it is existing.
4, yeah, it's 9x squared minus 16.
Yeah.
So 4 goes into the 16, but not the 9.
3 is 9.
Yeah, but we're saying, does anything go into both?
No.
Like a common factor. And there's no common factor. Okay?
But
So when we look at this, our hint, couple of hints here, well, besides the fact that I wrote that it's the difference of squares, but hint, there's only 2 terms, right? So it's either got to be difference of squares or common factor or prime, right? That's really our only options. So there's 2 terms. So that's the first hint. It is subtraction. That's the second hint. And then the third hint is if we can write this as something squared minus something squared, then ding, 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 we have a winner, right? So several of you have already said 16 is what squared? 4. 4 times 4, right? And then I've even had some of you say this one with the number part. What squared is 9? 3. And then does it make sense that x squared is x squared? Okay. So in other words, 3x times 3x gives us this, and 4 times 4 gives us this. So now we have this pattern, and I can't remember if I think I used capital letters, right? And here's the pattern. And we just use the pattern. So here's what this pattern says. This first piece, this is the A, and this is the B. So we're going to take the first part plus the second part. So we do have to make sure that we take this part, 3x plus the 4. And then for the second parentheses, 3x minus the 4. And then we're done, if you follow the pattern. Now here's the most common mistake if people are going to do this. The most common mistake they use is they just take this thing, and they stick it in over here and over here. You can't do that. That changes everything. So you've got to make sure you write it as something squared first and something squared. You got to do that first. And then these two values, the 3x and the 4, are going to go into these 2 spots. Okay? Now, if you don't like that and you don't want to memorize that pattern, we can do what we have been doing. And I'll show you how. Okay? I'm only going to show you this once because I would rather you learn this pattern because it'll save you time. But here's the difference. 9x squared and minus 16. The thing is, we're missing a term in the middle, right? We don't have 3 terms. What's automatically in the middle if there's nothing there?
1x.
It's not 1x.
X.
It's 0x.
Oh.
Right? Because we're adding. What is 0x? What is 0 times x? 0. So if I add 0 to something, I haven't changed it, right? So this is our sneaky way of getting 3 terms. That's why I say I wouldn't suggest this, but this we can do it.
So either or.
Yeah, so if we go through then and we multiply these, 9 times negative 16 is negative 144. So just the same as what we've been doing. This tells us that the signs are what? The signs of the two numbers we're looking for.
Either negative or positive.
One is negative, one's positive. Now here's the part where we have to be, whatever, you have to be a little careful. What does this tell us then? Which one is bigger? Neither. They add up to be 0, right? So if neither of them is bigger, I mean, we could start, they're equal. We could start listing numbers, negative 1 and 144 and blah, 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 blah. But we need two numbers that are equal that multiply together to be 144, right? You know what those numbers are? And if you're not sure, you can just keep going down the list. But it ends up being a negative 12 and a positive 12. 12 times 12 is 144. Okay? And if we do our steps here, here's what would happen. Minus 12x plus 12x minus 16. And again, do we see that this is true? It's 0 in the middle. If we do our grouping, I'm going to do this one kind of quickly because I think we've done this enough times already. But we could take out a 3x from both of these, and we would have 3x minus 4 left over. Take out our plus sign. We can take out a 4 from both of those, and we would have 3x minus 4. Not surprisingly, these are the same. We take out a 3x minus 4, and we have 3x plus 4 left over. And so we can see that that answer is exactly the same as this answer. All right. Now, I don't suggest doing it that way. I think this is probably worth your time to try and practice. And we're going to do another example like it, but you could do it either way. And either way, you get the same answer, 3x minus 4, 3x plus 4. Okay. So let's try another one of those difference of squares. And does anybody need me to wait? Okay. So my watch keeps buzzing because my family keeps messaging me and saying, did your class get canceled? Did your class get canceled? I'm in class. I can't respond to you, but whatever. Okay, are we good, everybody? Okay. So let's take a look at this one. All right. So now notice this one, two terms, right? So we're thinking maybe difference of squares, but what's the problem with our numbers here?
You can't.
12 is not a perfect square, and 75 is not a perfect square. But what have I been saying over and over, and we haven't been able to do it yet? Look for a common factor. Is there anything that goes evenly into 12 and 75? The answer is yes.
3.
3. 3 is it. So if we factor out a 3, and I'm going to put brackets here, what's left for the first term? 4m squared. And what's left for the second term?
25.
Correct, 25. Now, do we see that 4 and 25 are perfect squares? Okay, so here's what we want to do. We want to be able to, I'm using brackets just because I'm going to be using parentheses also. But we want to write down a perfect square minus another perfect square. I'll do this one first. What squared equals 25? 5. And then what squared will equal 4m squared?
2m.
2m. Correct. So do we see that we have the pattern we need? It's minus, and we've got two perfect squares. Now here's the deal. This 3 just sits out here. You don't do anything with it, but it has to stay there. And then we know we're going to get two parentheses, right? And what should we put in the first set of parentheses?
2m.
We don't need the squared. We just need the 2m and the 5. Okay? And then what goes in the second parentheses? 2m minus 5. Okay? The parentheses are just so we know what numbers should go in there. The 2m and the 5. Okay, so again, if you practice that one, I think that'll end up saving you some time. But it'll take a little bit of practice because it's probably new or reminders from long ago for most of us. Okay, so I think that's all the strictly factoring, but I wanted to show you one other thing before we go home. And here it is. I think we've got 2 examples of this. So how are we doing? What time is it? Almost 6:30. So we're going to get out earlier than 7 o'clock anyway. So the instructions here say, factor the following expression and solve. That means we're going to get x equals answers. We want to know what x values make this true. But we're going to use factoring to help us figure that out. So when you're going to do this, you always want it to be equal to 0. And I can't remember on the homework. I don't think there are any. But if it's ever not equal to 0, subtract or add or whatever you need to do to make it equal to 0 from both sides. Okay? Is there anything we can factor out of all of these? No, so there's no common factor. So what are we going to do? You guys tell me. You've been practicing, right? What are we going to do first? Yeah, if there is one, but in this case, there's no common factor. So what's going to be next?
4 times negative.
4 times negative 15. Oh yeah, let me read this first. 4x squared plus 4x minus 15 equals 0. Okay, so we're going to do 4 times the negative 15, and that gives us negative 60. Again, just calculator is fine. Or if you know it, that's fine too. What does the negative on this 60 tell us about the signs of the numbers, the factors we're looking for? Correct. And if you didn't hear, she said 1 positive, 1 negative. And we've done a lot of those tonight, so hopefully we're kind of getting that. And then, once we know that, they have to add together to be a positive 4. So what does that tell us? The bigger number is going to be positive. Okay, so we're just going to circle that to remind ourselves. And then we start listing our factors of 60. So again, I always start with 1 and 60, and I know the smaller one has to be negative. So negative 1 and 60, does that add up to be 4? No. And then we're going to go to negative 2, which goes in there 30 times. Does that add up to be 4? No. Negative 3 times 20. Does that add up to be 4? Still no. Negative 4 times 15. That's the one we did here. Does that add up to be 4? No. Negative 5 and 12. How about that one? No. Negative 6 and 10. How about that one? Yes. Finally, we got one, right? So 4x squared minus 6x plus 10x minus 15 equals 0. Keep your equals 0 there. Don't lose it. We factor by grouping just like we have been. All this stuff is going to be the same until the end. So what can we factor out of both of these? 2x. And what's going to be left here? 2x minus 3. Okay, and then we have our plus sign, so plus. And what can we factor out of there?
5.
A 5. And when we divide out the 5, what are we going to get? 2x minus 3. And again, they should be the same if we did our work right. And then they both have 2x minus 3. We can factor that out. And what's the other one? 2x plus 5. Now, here's the difference. We're not done yet. We're solving still. Okay, so all of this up to now has been exactly the same. But now we're going to use something that we learned way, way back a long time ago. Longer for some of us than others. Probably 2nd or 3rd grade. If I take any number and multiply it by 0, what happens? 0. We all like that rule, right? Because it's really easy. So here's what that means for us in this problem. We're trying to figure out what makes this true, right? And these two things are multiplied together, and they equal 0, right? So see if this makes sense. If this parentheses right here equals 0, and we multiply it by that, do we see that'll make that true? 0 times whatever this is will equal 0, right? So that means if 2x minus 3 equals 0, that's going to make this true, this equation. Also, if this part equals 0, and I multiply it by this, whatever this is, that will also equal 0, right? So our other option is 2x plus 5 equals 0. That's going to make it true. So the easy way to remember that is you just take each of these factors and set them equal to 0. Anytime you factor, set them equal to 0, and then you're going to solve. So now we have two little equations. How do we solve this first one?
Plus 3.
Add 3 to both sides to cancel that. So 2x equals 3, and then we're going to do what else? Divide by 2, so x equals 3 halves. That is one of our answers. And then we're going to do a similar thing over here. What do we have to do on this one? Subtract 5, right? To cancel this. And then we're going to divide by, oops, I'm ahead of myself here. And we're going to divide by 2. And we're going to have x equals negative 5 over 2. And those two answers, and again, you can go back and check with the calculator, and that will, both of those answers will work. Assuming you did everything else right, but they should work. Okay?
So if you plug it in again on the x, that should give you 0.
Yeah, if you take this 3 halves and plug it in for all these x's carefully and you do the work, it should equal 0. If you put in the negative 5 halves, plug it in, do all the work, it should be 0 also. Both of those should work. Okay? And I think I've got one more, and then we're out of here. Are we feeling pretty good about the factoring? Yes? No? Okay? We've done a lot of it, so you've gotten a lot of practice anyway. All right. What's that? Yeah, but not on the factoring. The test for chapter 2 is next week. We just had this because we were off a section, so we started the next section. So this will not be on the test. It's everything 2.1 to 2.5. That's going to be on the test. This is preview for chapter 3. Okay, so common factor? Nope, unfortunately this 29 messes us up, so we're going to multiply 5 times. Oh, I'm sorry. I keep forgetting. 5x squared plus 29x plus 20 equals 0. Okay, so we're going to take the 5 times the 20, a times c. That gives us 100. And the fact that this 100 is positive tells us what about the signs of the numbers we're looking for? They're both positive or both negative. So they have the same sign. Then, when we look over here at this 29 and it's positive, what does that tell us? No, that's what this one told us.
Oh, sorry.
But once we know that, if they add up to be a positive, they're both positive. Okay, so we know they're both positive, and we're finding factors of 100. Anybody want to save us some time with your factors of 100 knowledge? 4 and 25, right? Quarters. So 4 times 25. So again, if you're, whoops, not 4 and 10. If you're pretty good at your multiplication facts, you might be able to jump through this a little bit more quickly. Is everybody okay with 4 times 25 will work? So then we put these in. 5x squared plus 4x plus 25x plus 20 equals 0. And we factor by grouping. So we'll see if you guys picked the right numbers. I think you did, but you know, got to check it. So what can we factor out of the first group then? Just an x. And we will have what left over? Correct, 5x plus 4. And then we got to bring, yep, plus sign. And what else can we factor out of the second group? 5. And what's going to be left there? Switch that around. 5x plus 4. So again, they match up. We can factor out 5x plus 4. And we have x plus 5 left over,
0.
equals 0. So what do we do now? Solve it. Each of these factors equaling 0 would give us a solution. So 5x plus 4 equals 0 is going to be one of them. And x plus 5 equals 0 is going to be the other one. What do we have to do here? Subtract 4 on both sides. So to cancel that. So 5x equals negative 4. And then what? Divide by 5. You guys are shifting it into a turbo mode here. So x equals a negative 4/5. And then the other one's easier because there's only one step. What do we have to do over here? Subtract 5, and then we're done. X equals negative 5. Okay? And again, those two answers, if you plug them back in, you can check them, and it is correct. Okay? So, on the factoring, I think you have 10 of them. I think you have 10. I can't remember. I was looking through them to try and see if I needed to cut any out, but I think you got 10 of those. Okay? And again, guys, if you get stuck, I mean, if you have somebody else to help you, that's fine. But if you get stuck, don't be afraid to email me and ask me a question. I'm not terribly scary, just moderately scary. Okay? And again, next week, like I mentioned, we will have our test over just chapter 2, not what we just did with the factoring, just chapter 2, the linear type stuff. And I will be here as soon as I can after school. I can get here probably about 3:40, 3:45, something like that, and I will answer questions until about 4:40, if anybody has them. And then after that, we'll take our test and do the first section 3:1. Yes, ma'am. Oh, okay, yeah. So I've got it already set up for this week. The only thing that's due next week, Wednesday, is section 2.5. Okay, and then work on your review for the test review. That's also opened up now. I do give bonus points for that, so try to practice. That's why I do it, so that you hopefully practice it. And then this assignment, this one is due on the following Wednesday when the other, after we do the other lesson and stuff. So.
You said it's pretty open.